what question 2 says. It says you can use a positively charged object to charge a neutral. Remember we say that. There are 3 ways to charge. I want you to master this. This is not even complicated. There are 2 things, right? Remember when you charge by, there are 3 ways to charge. Friction, when you charge by friction, what am I going to have? 2 things, right? I'm just going to show you an example. A rod and a cloth. Let's say both of them are neutral. What do we mean by neutral? Both of them have the same number of positive and negatives, right? 15 positive, 15 negative, then in here maybe 10 positive, 10 negative. So overall we say they're neutral. Now what happens is you start rubbing this guy, you take him back and forth, okay? Back and forth. You start moving him against the cloth. What's going to happen is electrons will come from the rod, go to the cloth. And this rod will become positively charged. Why? In other words, we are just saying it now has a shortage of electrons. Now this guy will have an excess of electrons, too many electrons for the positive things he has. So he will end up being negatively charged. That is charging by friction. Charging by friction makes you have 2 objects that then have different charges. Both of them did not have a charge. Now at the end of the day, they will have charges. But when you charge by conduction and by induction, things change, okay? Conduction and induction. When you say you charge by conduction, it means you are going to get 2 things in contact. So you have a pith ball or whatever hanging in the air, then you bring a rod, and this rod is going to be charged. So the pith ball will be neutral. This one of the objects will be neutral. So one will be neutral, but then the other has to be charged. They can't be both neutral. So he will be charged. So the rod will be charged. And whatever the charge he has, we don't care. If he comes and gets into contact with this other one, let's say he's negatively charged. You know what's going to happen? If he comes and gets into contact with this neutral thing, then what's going to happen is the negative charge will flow out of him into this pith ball. And at the end of the day, the pith ball will get negatively charged. And when you remove the rod, you're going to leave the pith ball being negatively charged as well. So you came with a negatively charged rod and you left the pith ball being negatively charged. So when you charge by conduction, the thing you are charging will end up having the same charge as the thing you used to charge. Okay? This was the thing that was used to charge. He was neutral, remember? But now he's charged. He's no longer neutral. He's going to be charged. Now, when you charge by induction, nothing will go into contact with the other. Okay, they'll just come closer like this. If he is negatively charged, you know what's going to happen? Well, this is going to be the pith ball hanging. Now, there's going to be a cable connected to the ground here. Then this is neutral. Remember, he's going to be neutral, right? Neutral, you leave him neutral. Then you know what you first do? You can, before you connect the cable, he's going to be neutral, right? Then what you do is you bring this negative charge close, and you know what happens? The charges were evenly distributed, but what will end up happening is the positive will move here, and then the negative will go to this corner, right? Because they are moving away from this negative. Remember, like charges repel, and unlike charges attract. So the positive will come here. Then you can come and connect to the earth. Then this negative will flow out, and the negative will flow out. Then by the time you remove the rod and move it far away or remove it, this will remain being positively charged. So what happens when you charge by induction? The object being charged will remain with an opposite charge to the one charging it. Now let's answer the questions and let's see if we can answer them. I know you can. Only 2 marks. You're not going to lose marks to this. It says you can use a positively charged object to charge a neutral object by conduction. Yes, true. Or by induction. Yes, true. You can use a charged object to charge a neutral object. Okay? How? Either by conduction or by induction. One has to be charged, the other one neutral. So here one is charged because it's positively charged. The other one is neutral. Yes, so conduction and induction both work. Now here they say, which type of charge will the neutral object acquire if charged by conduction? Well, the neutral object is the one that was uncharged. Which type of object would it, and then they said explain. So you can say neutral object. If you charge by conduction, remember, neutral object would acquire positive charge. Okay, you are charging by a positive object, so it will acquire positive charge. Okay, and what is the reason? Now we can answer. What is the reason? Here is the reason. The object, we can now just write to say the object being charged, we can always say the object being charged by conduction, the object being charged by conduction is always left, you can say is always left with a charge, having the same sign, okay? With a charge having the same sign as the object, I can say as the object doing the charging. This is good. Doing the charging. This is so easy. I mean, you can remember it in your sleep that the object being charged by conduction is always left with a charge having the same sign as the object doing the charging. Now, here it says, which type of charge would the neutral object acquire if charged by induction? Now, we talked about induction and we said that induction causes the object being charged to remain with an opposite charge to that charging it. So here, what is the object charge doing the charging? It is a positively charged object. So the neutral object will then become negatively charged at the end of the day. So you can say neutral object, this is the first statement you write. You're going to say that the neutral object would acquire negative charge. Then you get 1 mark. The other mark is now you have to then explain why. Because the object being charged by induction, you should write that. Say the object being charged by induction, okay? You can write to say the object being charged by induction is always, same statement but different to the one we wrote, is always left with a charge having the opposite sign, okay? Having the opposite sign as the object doing the charging, okay? As the object doing the charging. So this is going to be it. The object being charged by induction is always left with a charge having the opposite sign as the object doing the charging. And you are done. This is going to be your solution. We're going to go to number 3. We'll do it in the next video. Goodbye for now.